Good morning, ladies and gentlemen, on this beautiful April 20th, 2020. Wow, 2020. A lot of 20s today. You might see that something is different about me. I am wearing my Star Wars shirt, if you can look very closely on that. But hope you're all having a wonderful Monday. What we're going to talk about today is square roots. Mainly how they look, how they operate, and what do they mean algebraically. Because I often feel that square roots are something that we kind of avoid as mathematicians and as students to work on other things, because sometimes square roots are hard to manipulate. One thing I definitely want to emphasize is that a square and a square root cancel each other out. They are inverse operations. If a square, if I multiply something by itself to get it larger, like x times x gives me x squared, then if that's squaring something, increasing its exponential power, then a square root is its inverse. I am decreasing its exponential power. Instead of multiplying two things to get a larger one, I am taking something and breaking it apart into two separate things. One thing I definitely want to emphasize is that is not the same thing as a division. A square root is not the same thing as a division. They look similar and they behave sometimes similarly, but no, they are definitely not the same thing. Now, we could show that a square and a square root cancel each other out through some algebraic manipulation. I know that if I have an index here, or if I have a value here, that the square root, there's technically a 2 here. And that 2 is going to come around to this side, underneath this root. And 2 divided by 2 is going to give me 1, and therefore the root, the exponent, cancel each other out, leaving me with just x. And this will make more sense when we work on it tomorrow, but I just want us to understand, okay, this is how a square root works. This is why a square root works. And so, the same thing also applies to normal integers. I can recognize, I apologize, my brain just skipped a beat, I don't know where I was, or don't know what, forgot what I was talking about, but that integers function into the same thing. If I have something like the square root of 9, I can see that's the same thing. Oh, 9 is 3 squared. The 2's cancel out, leaving you with just 3. Now, it is sometimes hard to talk about why a square root does this, especially when you get to this stage, because like, hey, if I already know that 9 is 3 squared, then why am I doing a square root? Well, a lot of it's algebraic manipulation, understanding that, hey, I'm going to be moving this around, I'm going to be dividing this out, or I'm going to be splitting this apart. A lot of it just comes through practice of knowing, okay, this is what happens when I break down the square root. Now, I'm going to write out the process for the square root of 16 times x squared to the 4th. I apologize. A yawn attack just there. Now, when this happens, I can take care of these individually. And you can do that with most square roots. I can write this out as a square root of 16 times square root of x to the 4th. Now, if I know that a square root has a 2 in there, then this is square root of 16 times the square root of x to the 4th. Now, we should all know, hopefully, that the square root of 16 is 4. So that's the square root of 4 squared times x to the 4 over 2. I wonder if I should have given this lesson out of order. But obviously those 2's cancel out, so you're left with 4. 4 divided by 2 gives you x squared. So the square root of 16x to the 4th is 4x squared. Now, the main reason that I wanted to, actually never mind, let's go on this one. Do this check for understanding, break this square root into its 3 parts, and then simplify it. You can do it definitely. Pause the video, take 5 seconds, work on it on your own. And there we go. So, what I obviously would want to do is break this into 3 parts. And when you break into 3 parts, just do the normal square roots. Square root of 49 is 7. Square root of x to the 6th is x to the 3rd. And square root of y to the 10th is y to the 5th. And you might say, oh, you're just dividing in half. Well, we're dividing the exponential power, not dividing the y itself. Like, 49 divided by 2 is definitely not 7, but the square root of 49 is 7. But, yep, this is our answer. And I was saying previously, when we do square roots, often I see students just punch in something in a calculator and they just write a decimal. And that's totally fine, normally. Like, if I say, like, the square root of 10, hand it in a calculator. You should always have a calculator in hand, even if it's just your phone. I would have a lot of students say, oh, that's 3.16. And that's approximately, that's why you get little squiggly signs. 3.16. It's approximately that, but it's not exactly that. It's, if I remember correctly, it's 3.1625, but because of rounding, we rounded to 3.16. So, one thing I really want to focus on right now is that I want to give us an equivalent to the root. Breaking it down where I don't have decimals, but I just have roots. Like the square root of 10, since it doesn't break down evenly, but you can't break it down into anything else, you would have to leave it, unfortunately, as square root of 10. I don't think I'm saying that out. I don't think I'm saying that out of order. What I want us to do is to take down any square root and break it down between a perfect root that breaks down evenly and something that doesn't break down evenly. Because just like this, we broke this down into 3 parts, right? I want us to be able to break down our roots, our numerical roots, into multiple parts, where some break down and some don't. What you need to know for all that is what your perfect roots are. Your perfect roots are 1, because what's the square root of 1? 1. What's the square root of 4? 2. Or let's say that backwards. What's 3 squared? 9. That is a very funky 9. What's 4 squared? 16. 5 squared? 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 100 squared is I just said it. 10 squared is 100. And 11 squared is 121. This obviously continues with like 144, 169, 196, 225. So it keeps going, but normally when you're breaking down perfect roots, you're only going to break it down into these ones. Anything beyond that is unusual, but totally workable. And I should have written this somewhere else because this kind of gets in the way. Let me get an eraser. But this is just seeing this in action. Alright, there we go. Like 24? 24 doesn't have a perfect square root, but I do know that 24 is the product of two roots. What's 4 times 6? 24, right? And while 6 doesn't break down evenly, we know 4 does. The square root of 4 is 2. So this, and obviously these 2's are going to cancel out, so the square root of 24 is 2 times the square root of 6. Now, what you want to do is go for the largest root possible. Like 240, if I have the square root of 240, I know that 240 is divisible by 4, or at least I highly suspect it's divisible by 4. It is, but that gives me the square root of 60, which would also be broken down. I want to break it down to where I have a perfect root on one side and a root that cannot be broken down by anything else. Like this 240 is going to be the square root of 16 times the square root of 15. Now this is good because I know that the square root of 16 is 4. And you might say, but hey, Mr. K, 15 breaks down to 5 and 3. That's true. But 5 and 3, neither of those, are a perfect root. They don't break down perfectly on a square root. So I have to keep this as a square root of 15. So the square root of 240 is the same thing as 4 square roots of 15, which is more accurate than I believe would be 15 point something. Yeah, 15 point something. Anyways, let's try the next one. 245. Now you might think, oh hey, 245, that's super close to 240, it's got to be square root of 16 and something. No, not at all. I know that 245 is divisible. It ends in a 5, so it's got to be divisible by 5. Let's see if it's divisible by 25. So 245 divisible by 25 gets me a 9.8. So that doesn't work. But 245, what if I divide it by, I don't know, 49? 245 divided by 49, it's going to be 249 times 5. So this is going to become that. And I think we're going to take an extra day to work on these because square roots can definitely trip people up. But square root of 49 is obviously 7, and there's nothing I can do with the square root of 5 because it's a perfect square. I mean, it's a prime number. My apologies. And so square root of 245 becomes 7 square roots of 5. So we're on the last one. I want to write this without any decimals whatsoever, so I need to know if it's divisible by 4, 9, 16, 25, 36, 49, so on and so forth. So on and so forth. Now, I know that 468 is divisible by 16, because that's going to be... Actually, no, it's not. 468 is divisible by 4. It's divisible by 4. But I don't want to use 4. I want to use the largest one possible. It's not divisible by 49. And it's not divisible by 16 or 25. I'm going to try 36. And if I do 36, that's the same thing as square root of 36 times the square root of 13. Now 13 is definitely good because 13 is a prime number. I can't break that down. So square root of 36, 6 times the square root of 13. But this is going to be our answer. Square root of 468 is the same thing as 6 square roots of 13. Now, I think we are going to do a little bit more practice tomorrow on this, but hey, that's fine, that's dandy. I'm totally fine with doing more square root practice so we can understand what we're doing. But ladies and gentlemen, hope you have yourselves a wonderful Monday. Stay safe. Have a nice day.